And good day, pre-algebra. We are kicking off the week with a squeak and PO54, graphing an equation in slope-intercept form. So we've graphed equations before, but when we did it, we had to make what's called a function table, right? We plugged in a value for x into the equation, we solved for y, we plotted the point, and it took a lot of time. There's actually hints that an equation gives us that allows us to graph it very, very quickly and relatively easily. And that's called slope-intercept form. There are three equations that you will learn under my tutelage this year and next year. Slope-intercept form, as I say, three, you'll learn a lot of them. Three most important equations. Slope-intercept form is definitely one of them, okay? And what slope-intercept form is, and it sounds like this is new for everybody, is y equals mx plus b. Huh? Okay, a lot of variables. Y equals mx plus b. Now, the y and the x, they're probably the most familiar to you because the x variable represents the x value of any ordered pair that's on the line, right? You can pick a value for x, you can plug it in, you can solve for y, and that's going to be an ordered pair that's on the line. So you've done this before. You've worked with x before because you picked the value for x, you plugged it in. That's the whole function table thing there, okay? And the y would be kind of the same thing, only it's the y value of any ordered pair on the line. Okay? So if you're graphing this equation with a function table, that's what you would use. You use the x and the y, you pick a value for x, you plug it in, solve for y, plot the point, and go on with the day. But we are going to focus on the m and the b because the m and the b are the variables that are going to allow us to graph this with relative ease. And the m variable represents the slope. We've done this before. What is slope? What is slope, Tristan? Rise over run, right? It's that change in y over the change in x. It's the vertical change and the horizontal change. We found slope by looking at a line on the coordinate plane. We found slope by using a slope formula, okay? But the m variable is the slope. And the b, thank you, objectives 52 and 53, the b is the y-intercept. The b is the y-intercept. And of course, the y-intercept is where the line is going to cross the y-axis. Okay? So when you have an equation in slope-intercept form, we know where it's going to cross the y-axis because that's what the b variable tells us. And then, by using the slope, we can find a second point by using the rise over the run. So no need for a function table. We have all the information that we need to know to graph this right here. Okay. So the steps to graph an equation in slope-intercept form. First of all, make sure the equation is in slope-intercept form. Write the equation in slope-intercept form if it isn't already there, because you will come across equations that aren't in slope-intercept form for you. And we'll talk about how to convert them later on. Okay. But in step two, kids often ask, why is the b variable the y-intercept? Why wouldn't we use y for the y-intercept? It would make more sense. Well, y is already used somewhere else in the formula. Okay. Well, then why don't we use like an I for y-intercept? Why a b? Okay. Well, in actuality, when y-intercept and slope-intercept form and all that stuff was kind of first being discovered and used and taught, it was called the y-bintercept. But over time, languages change, right? Things get added, dropped. The b was actually ended up being dropped off that, and it stayed as the y-intercept. But we use b because originally it was called the y-bintercept. Also, it's where you begin. Begin by plotting the y-intercept, which is that b variable. Okay? B for begin. Begin by plotting that y-intercept, which is the b variable. And then the other question that kids often ask is why m for slope? Why not s? Right? That would even make a lot more sense. Well, back when slope-intercept form was first being discovered and used and taught, it was actually called the MLOP. Okay? But then, over time, languages changed, lost in translation, it became slope. Okay? Also, that's because you move using the slope to find a second point. Okay? You move using the slope to find a second point. So you begin with the b value, you move with the m value. Question so far? Okay. Well then, let's just go ahead and practice. All right? Here we go. Down below, you've got 3 coordinate planes. You've got 3 equations. In the first one, y equals 2x minus 3. Recognize, this is in slope-intercept form here. Y equals mx plus b. Okay, look at those pieces. The y and x variables are still y and x in the equation because you can plug things in for those, right? But the m has been replaced with a 2. The b has been replaced with a negative 3. So when we go to graph this, we're going to begin with our y-intercept. What is the y-intercept? Where is this line crossing the y-axis? Well, it's crossing it at negative 3, right? Whatever that number is that comes after the x term, that's your y-intercept. That's where this is crossing the y-axis. We can go ahead and put a point at negative 3 on the y-axis. Okay. Well, why does that work, Mr. Schultz? Well, remember what a y-intercept is. To find a y-intercept, what variable are we setting equal to 0? And feel free to answer, because this isn't a joke.
X value?
The x, right? And so if we take this equation, y equals 2x minus 3, and if we set x equal to 0, which is going to eliminate this x term, what are we left with? Y equals negative 3. There it is right there. Okay? So it works because, we don't have to do this math. We can just look at the b value and see that's where it crosses. But the reason why it works goes back to the definition of a y-intercept, and that when x is 0, that term gets eliminated, and we're just left with negative 3. Okay? Now, we move using the MLOP, or the slope. What's the slope here? We see that m has been replaced with 2. How is 2 written as a fraction? How do you write the number 2 as a fraction?
2 over 1.
2 over 1. So our slope, 2, that looks like 2 on top of a t. 2 over 1 means from that y-intercept point, we are moving up 2 over 1. Up 2 over 1. And how many points do we need to make a line? Just 2. We got them. The first one came from the y-intercept. The second one came by moving, using that slope to find that second point. And here's our super straight, super accurate line. Ta-da! You just grabbed an equation using slope-intercept form. No function table needed. There you have it. I mean, and we could test this too, right? It looks like our line passes through this ordered pair right here. What is that ordered pair? Nolan?
2, 1.
2, 1. Which means that if we plug in 2 for x and 1 for y, that equation should be true. Because remember, x and y represent any ordered pair that's on the line. 2, 1 appears to be on the line. So let's test it. Let's plug in 1 for y, our slope of 2, 2 for x, and then our minus 3. 2 times 2 is 4. 4 minus 3 equals 1. It works. Okay? It appears that this ordered pair is on the line as well. 3, 3. Let's test it. Okay? 3 in for y. Our slope of 2. In this case, our x value is also 3. And we're subtracting 3. 2 times 3 is 6. 6 minus 3 equals 3. The equation works. Okay? Any ordered pair on this line you can plug in for x and y, and it's going to make the equation true. And that's how we'd have to graph it using a function table if we didn't have slope-intercept form. But now you do. So life just got a lot easier. You're welcome. Thank you. Thank you all. Very good. Let's look at the next one. Y equals negative 3/4 x plus 1. Again, recognize that we are in slope-intercept form. Y equals mx plus b. We are going to begin with our y-intercept, which is what? Positive 1. Okay? You do need to pay attention to that sign, right? Why is this positive? Because it's a plus 1, a positive 1. Our last one was negative because it was a negative 3, minus 3. That sign belongs to the number. So our b value is positive 1. That's the y-intercept, 0, 1. We're putting our first point right there. And then what's our slope? How are we moving? What's the value for m in this equation? Good. Negative 3/4, right? That sign belongs to the 3/4. Remember that negative sign doesn't belong to both of them, though, right? It's not negative 3 over negative 4, because that'd be positive. So we're going to think of that negative sign being with the 3. Okay? Which means that from this y-intercept, we're going down 3 and then right 4. That's how we're moving. Down 3, right 4. There's our line. You say insane? Isn't that? Yes. Finally, some emotion. I love it. Yes, it's insane. It's great. Okay? You don't have to deal with fractions, plugging values in, anything like that. Right? Let's look at the next one. Y equals x plus 3. This one tends to throw kids a little bit because when they think about y equals mx plus b, they say, wait, where's the m? Right? We've got our y variable. We've got our x variable. B is positive 3, but where's the m? What is the value for m? If you've ever been bored, which would never happen, but if it did, and you looked around the room, you see that hidden math poster in the back there? The orange square says x is the same as 1x, right? When we have a coefficient of 1 in front of a variable, we don't write it because mathematicians are lazy. And it's like, well, there's no number written there. We're just going to mean that's a 1 because it has 1x. If we have 2 x's, we have to write the 2. If we have negative 3/4 x's, we have to write that. But if there's only 1x, we don't write the 1, but it's still there. Okay? So this is the same as y equals 1x plus 3. Which means our y-intercept is, Gregory? 3, right? 0, 3. It's that b value there. It's plus 3, so it's positive. And our slope, how are we moving here? if m is 1, how do we write that as a fraction? Zoe? 1 over 1. Very good. Okay, 1 over 1. So we're starting at 0, 3, and we're moving up 1 over 1. Okay? Up 1 over 1. There's a point. You want to do it again? Sure. Up 1 over 1. We can keep going up 1 over 1 for as long as we want to. And we're, well, so you run out of space, I suppose. And that's going to give us ordered pairs on the line. Okay? We can test this too. It looks like 4, 7 is going to be on the line. Right? 4, 7. If we plug in 4, 7 into our equation, does it work? Well, 7 for y, 4 for x. Is 7 the same as 4 plus 3? Yes, it is. It works. Okay. Questions, comments, concerns, complaints, compliments, congratulations, criticisms. Okay. For practice, for homework, for tomorrow, looking at this second page, you've got 9 of them to do. Okay. They're all in slope-intercept form. I don't have you write the y-intercept and the slope down like I did in the first 3 there. If you want to, I would recommend it. The one that people have questions about, this third one here, y equals 2x. If we look at our equation, y equals mx plus b, well, it's got a y. It does have an m. It's got an x. There's no b. What does that mean it is? Not a 1 this time, because if you were adding 1, you would have to write that because that changes the value, right? What number would you add to 2x? That's not going to change anything, so we don't have to write it. 0. If there's no b, it's like there's a plus 0, right? Because if you're adding 0, nothing changes. Why write it? We're lazy, okay? But you have to understand it's there. It's what it means. So if there's no number before x, it's a 1, because we have 1 of them. If there's no b value, it's a 0, because adding 0 to something doesn't change it. Okay. Anything you wanted to do together with the 7 minutes we've got remaining here? No? Tristan?
The y equals x1.
Y equals x. Yeah, this is like the culmination of hidden math here, because we've got our slope-intercept form, and all it gives us is a y and an x. So it kind of combines what we just talked about. If there's no m written, what is it? If there's no m written, there's no number written before x, what is it? 1, because we do have 1x. If there's no b written, nothing's being added to this. What is it? Gregory? 0. Nothing's being added. Well, 0 is nothing. Okay? So our equation, or our graph, our y-intercept is 0, which means it's 0, 0, passes through the origin. And our slope, 1, is 1 over 1, up 1 over 1, from the origin, up 1 over 1, up 1 over 1, up 1 over 1, so on and so forth. There's your line. Okay. Others, I'll do one more with you. If you want. Nope? Okay, well, this is homework for tomorrow. You've got 6 solid minutes to work. Slope-intercept form. Look back, if you need to, on what the B is, what the M is, how to use them. But homework for tomorrow, that is how you math.
Don't forget to like and subscribe.